Today we're going to work on transformations of functions. I'm going to go through this very slowly, step by step. It is so important that you understand transformations in grade 11. It's introduced here in chapter 1. It's repeated again and again throughout the textbook and the curriculum. So you will need to know how to do this really, really well. So spend the time going over this video very carefully in order that you master it, because again, I'm telling you, it's going to hit you again later on in the book. So let's go over some of the very basic moves that you learned back in grade 10. The handout that I'm using here, I'll write the link again to below in the comment section, and you can access it, download it, print it out, use it. Go over this again and again until you understand what we're going to be putting in each and every one of these boxes in the next, I don't know how many pages, there's lots of them. So I'm going to start today. We'll see how far we get in about 20 minutes or so, and then I'll set another video to do the next parts. So the first step, we're going to talk about vertical. Vertical, remember, is up and down. Horizontal, you should see the word here, horizon. So that means left to right, right? It's going this way. Vertical is up and down, vertical. Think about the horizon. That'll help you to remember horizontal, vertical. Maybe the vertical drop of something. Maybe you're a skier. You know vertical drop is important for how fast or how slow you want to go. And translations just means the shifting and moving around of a basic parent function, which we've already discussed. So the first transformation we're going to talk about is a vertical translation. It is represented by a K. K means moving up or down, depending on whether K is positive, you go up, and negative, you go down. And the H here is a horizontal translation of H units. Now we're going to talk a lot about how this one works, because people get this one. This is the one that mixes people up the most. So let's start with the basic vertical translation here. So we have f at x. So we're just talking about some function, f at x. It could be the graph of x squared. It could be the graph of the root of x. F at x just says I'm going to use some function. Now it doesn't even have to be something as complicated as x squared or root x. It could be just a series of points. It could be some crazy shape on a graph, and they'll say, I want you to do a transformation on this. I want you to shift this transformation. Even if it was a pen, I want you to take this pen and I want you to shift it up, K units. So you move it up. I want you to move it down. So you move it down. So you see, it's just a movement, vertical, up and down. So how would you write this in terms of x squared? So if f at x is x squared, see on this line it says f at x is x squared. What's f at x plus 3? And you'd say, well, that just means y is going to be equal to x squared plus 3, because x squared is the graph that I'm using for my function. F at x minus 1. Oh, so I'm going to call that one y equals x squared minus 1. The root of x, well, this will be my f at x. So if I want to write that as the transformed function, it would be the root of x. I'm just going to take the function root of x, which is just my f at x here, and I'm going to move it up 3. Or in this case, I'm asking you to take the function root x and subtract 1. So how does that look on the graph? So here, what they've done in the dotted line, this is a sketch of the function x squared. So it's a parabola, right? 1, 1, 2, 4, 3, 9. And this is the root of x. Remember, it starts at 0, 0. A very critical point in the graphing of the root of x is to know where it starts. So now what I'm going to do is I've got these fancy neon pens. Let's see how they work. And I want to sketch x squared plus 3. So what you need to remember here is that we haven't changed the shape at all of the root of the x squared function. We're just taking the whole thing and moving it up 3. So I'm going to go up 1, 2, 3. So here's my vertex 0, 0, now is at 0 and 3. The next point, you should know that if you go over 1 on a quadratic, you go up 1 for x squared, over 1, up 1. So I'm going to go over 1 and up 1. And because parabolas are symmetrical about the line y equals x here, sorry, y equals 0, x equals 0. Oh my goodness, I'm getting all confused myself here. And if I go over 1 more, I'm going to go up 3 more. And so my parabola is just shifted up 3 units. So it's the very same shape, but it's been shifted up 3. And I'll just put a little blue line here so you know that that one matched with that one. And then if I take the parabola x squared and I move it down 1, all I do is take this and move it down 1. So over 1, up 1, that's my first point. It'd be here. I would go over 1 and I would go up 3 more, 2, 3. And I go over 1, I go up 3 more, 1, 2, 3. These are sketches, okay? I'm just sketching it. Doesn't have to be perfectly accurate. But you should be able to see that I haven't changed the shape of the parabola. I've just shifted it up or down k units. Now the same thing with the graph of the root of x. If I want to translate this up 3 units, I just move it up 3. 1, 2, 3. There's where it's going to start. So that critical point, which was 0, 0, became 0, 3, right? So 0, 3. So the point 1, 1, 1, 1, I'm going to shift it up 3. That's affecting the y's. So I add 3 to the 1. So 1, 4. 1, 4. There it is right there. And another key point here would be 4, 2. Right? So 4 and 2, the square root of 4 is 2. And I'm going to shift it up 3. So I add 3 to my y values. And I would have 4, 5. Right about there. And I'm just going to sketch it like that. And the graph of the root of x minus 1, of course I move it down 1. So 0, 1, 0 becomes 0. This is now 0 minus 1. So we're going to talk a little bit about mapping rules later. So I've mapped it down 1 unit. And this one that was at 2 and 4 is, 1, 1, 1. Let's go 4, 2. So it's going to be 4 and 1. And that's going to be enough for me to make a sketch like that. Okay, so that's what we call a vertical translation. Up if it's positive, down if it's negative. So now let's move on to the next one, the next graph here. I'm just going to slide this up so you can see clearly. And I'm going to use, I'm still using f at x up here as x squared, and I want to do f at x plus 4. So what you have to see here is that the x plus 4 is what we're going to be substituting in for the x. So if I was to write the new function, or the equation of the transform function that's going to be shifted, I would write it as y equals x plus 4 in brackets n squared. And x minus 2 will be y equals x minus 2 squared. So remember that this function notation, remember we did that previously, that whatever is in the brackets gets plugged in for the x. So for the root of x, that means this is going to be y equals the square root of x plus 4. And this is going to be y equals the square root of x minus 2. So you plugged it in. You don't need the brackets here because it's under a radical sign, but you definitely need the brackets here because you're squaring it. Everything in the bracket squared, everything under the radical sign. So either this way or this way, it would be fine. Okay, so this is a horizontal translation. And horizontal translations, I'm going to tell you right now that x's, anything to do with x, horizontal, of course, is an x change because it's moving left and right, right? Vertical means y, up and down. That's the height of my function. So if it says x plus 4, it's going to be shifted. Hope you get this right. What way does it go if it's plus 4? If I asked you where's the vertex of this function, you'd probably automatically tell me minus 4 and 0. So x's are weird. First thing you need to know about transformations. X's are weird. If it's in the brackets, it's kind of like a hermit. It stays inside. It doesn't do anything. And it's wrong. So it says plus 4. It's going to go to the left 4. They do weird things. So it's going left 4. 1, 2, 3, 4. So here's my left 4. Plus 4 goes to the left. So this means left. This minus 2 is telling you the graph has to go to the right 2. Okay, so horizontal shift right. And if you look at the original function up here of x minus h, so it's the minus of the h, the minus of it. So minus plus 4 is minus 4 means left. Minus minus 2 means plus 2. That means right. Okay, so let's move this one, finish the sketching for it, and try it with the radical function. So I've moved it to the left 4. Plus 4 goes to left. Okay, you have to remember, x's are weird. If it looks like plus, it goes left. You'd think plus would be right, but this time it's going to be left. So I'm just going to sketch this quickly because I don't want to spend too much time. I'm just trying to get it in the right position. So that's x plus 4 squared. And the one in pink here, x minus 2, means shifted 2 units. 1, 2, to the right. Over 1, up 1, over 1, up 1. The shape of the function is not changing. It's the very same. We haven't done any stretches or compressions. It should look the same, but just moved over. So if you could just make a carbon copy of this parabola, you could just move it left and right. Now this one, now we have the radical. So we have the square root of x plus 4. It's moving left again. Remember, plus 4 means to the left 4. Left 4. 4 units, you should say. And this is going to be right 2 units. Right 2 units. I highly recommend that you print this out and try it. The more you can't just learn by listening and watching. You have to do. Math is all about, is a participation sport. Okay, so this one to the left 4. 1, 2, 3, 4. I put it here. The square root of 1 here was 1. So if I go over 1, I go up 1. And the square root of 4 was 2. So I'd have to go over 4 from here. 1, 2, 3, 4, up 2. And there's my horizontal translation to the left 4 units. And now I'm going to move the other one to the right 2 units. So I go 1, 2. And that's my 0, right? 0, 0 to 0, 2, 0. And then I go 1 and up 1. And I go over 4. 1, 2, 3, 4, and up 2. And there's a nice sketch of my graph of y equals x minus 2 in brackets under the radical sign. Okay, so let's move on to the next one. So this might be on the second page for you. I had a little bit of trouble reformatting it, but it's all there. Let's see, we'll get you on the screen. Okay, so let's take a look at this function here. I have f at x minus 2 plus 1. So how am I going to write that as the equation of the transformed graph of x squared? So again, if my f at x is x squared, that was way up here. We started here, remember? So I'm going to plug in the x minus 2 in for x. So this equation will become y equals. This is plugged in for the x. So it's going to be x minus 2. The function is x squared, so I have to square it. And then the plus 1 says I'm going to shift it up 1. And the second function, x plus 3, goes in for the x in brackets squared, then minus 2. So y equals x plus 3 squared minus 2. And for the radical function, I'm going to say, well, that's y equals my x minus 2 gets plugged in where I had the x in the equation. So that's under the radical sign. And the plus 1 is outside the radical. It's outside because I'm only plugging this in for the x. The plus 1, just like we did up here, when we moved up 3 or down 1, these were my vertical translations up and down. Okay, so we're getting this under control here, right? So now I have this. I write in the radical sign, and I plug in what was for x. X was supposed to be x plus 3. So I'm going to do plus 3. And then outside of the radical, just like this was outside the brackets, I go down 2. So what does this mean? What do I have to do when I go to graph this? So the first thing you need to do is say, okay, so I'm going, this says minus 2. X's are weird, right? They're weird. I'm not going to go left 2. I'm going to go right 2. So I'm going to go right 2. And plus 1 says I have to shift it up 1. Now, I bet from grade 10 math, you should know that the vertex here, all right, vertex, the vertex is 2, 1. 2, 1. What's the vertex for this one? We'll do it in pink. Vertex here is, x's are weird. Okay, it says plus 3. No, it's minus 3. Minus 3 and minus 2. Minus 3. 1, 2, 3, minus 1, 2. That puts it right here. Okay, so once I know where the vertex is for a quadratic, it's really easy to sketch the rest of it, knowing your pattern. Then if you go over 1, you go up 1. If you go over to the left 1, you would go up 1. And then if you go over 2, 1, 2, you should go up 4, 1, 2, 3, 4. So something like that. And I'm just going to eyeball the other one here. It's going to be there. Okay, so here's my parabola. It's beautiful. It goes like that. The other one, the pink one here, so it was plus 3. I go to the left 3, down 2. So you could take every point and go left 3 and then down 2. Or you could use the step pattern for a quadratic, which means you go over 1 because it goes 0, 0, 1, 1. So over 1, you went up 1. So I'm going to go over 1 and up 1. And if I went over 4, so the square root of 4 is 2, right? So, sorry, 2 squared is 4. So if I go over 4, 1, 2, 3, 4, I should go up. Sorry, I'm getting this backwards because I'm thinking radical, right? I go over 2 and up 4. So over 2, up 4. 1, 2, 3, 4. And because parabolas are symmetrical, I'm right over here as well. So there's your lovely quadratic move to the left. Left 3, down 2. Left 3, down 2. Okay, now the last one we're going to do is this radical one here. So we have minus 2 plus 1. So it's the same transformation, but it's being applied to the radical, the square root of x. So I have to know where the key points are. And again, key points on this function are this 0, 0, 1 here, 1, 1. The square root of 4 is 2. So these, if I know these 3 points and I can do the transformation on those, I will be able to do a pretty decent sketch. So I'm going to go right 2, up 1. So go right 2, up 1. That's where my 0, 0 went. This point goes to here, right? So this one, I'm going to go right 2, up 1. And just going to do a nice little freehand sketch of that one. And for left 3, right? It says plus 3. No, eggs are weird. You go left 3. So here's my 0, 0 point. Go 1, 2, 3. Left 3, down 2. 1, 2. So that one goes here. left 3, down 2. That's my 0, 0. So the other point, the next point that's a key point on my graph, remember I said 1, 1? So 1, 1, which is a key point, I'm going to go left 3. Left 3 from 1 is minus 2. And 1, go down 2 from 1, that makes minus 1. Minus 2, minus 1, right there. And I knew that was over 1 up 1 from this point. So if this was right, this was just 1 over 1 up. Now let's do the point 4, 2, just so you can see exactly where it should go. So 4, 2, it says I'm going left 3. So left 3 means I'm changing the x. I go left 3 from 4, takes me to 4 minus 3, 1. And 2, go down 2 from 2, takes me to 2 minus 2, 0. So 1 and 0. There's the other key point here. So I'm going to sketch this like that. And there's my radical sign. Okay, so we'll leave that for here. Let me just see what's on the next page. Oh, we're going to do reflections. So reflections will be what we do next in the next lesson.